Hey there, here we have a quadratic equation that needs to be solved. Directions are asking for all solutions, not just real solutions, so hint. And in this particular example, we need to do some rearranging before we start. The equation that we are looking at has a quadratic monomial on the left and it has a linear binomial on the right. If this were tied to a visual, we would have a slightly more narrow parabola located with its vertex at the origin, intersecting a linear equation. Slope is -6 with the y-intercept of -7, and we'd be curious about where are they intersecting. If you are able to visualize that for us, this graph here I just described is a parabola, slightly more narrow. It had a vertical stretch of 2 applied to it. Okay, vertex at the origin. And here I have a slope of -6 and a y-intercept of -7 on a linear equation. So quick sketch right over there. When we're solving this equation, we're really solving a system of equations asking us to figure out where those two things intersect. First glance here, looks to me like the only place they might intersect is maybe in this direction as they go to the right. Clearly, as x gets larger and larger, they are going in opposite directions. The quadratic or the parabola is going up towards infinity, the end behavior is up, and the linear is going down towards -infinity as x goes to the right or to infinity. As x goes toward -infinity, however, both the parabola and linear equation are going up towards positive infinity in the y values. So if they're going to intersect, it seems like it'll be there. Here, however, this is a steady, constant slope. It's -6. This is getting steeper and steeper and steeper as it goes up, so I don't think they're going to intersect. Spoiler alert. So we'll probably get, you guessed it, imaginary solutions. So let's get into it. First thing you want to do in a situation like this is, well, you want to show your work. If you're watching this video, then you're probably not an expert just yet. So if you want to add 6x and you want to add 7, make sure you're writing it down. A lot of you will think it and then write down what's already on the other side, but on the left, and that's just not how it works. 2x squared, 6x, and 7 are not like terms. Nothing can combine. This here is our quadratic trinomial in standard form, equal to our happy 0. We like to solve by factoring whenever possible, and then once it's factored, we could apply what we call the zero product property, where we set each factor or piece of the product equal to 0 and solve. But this won't be factorable. So if we tried the AC method and grouping, AC would be 2 times 7, which is 14. Then I'm not going to try to be a hero. I'm going to go through everything. 1 and 14, 2 and 7. That's everything. Do we have a pair of numbers on our list that can add or subtract to give me 6? No, we don't. So what do we need? We need the quadratic formula. If you're watching this video, you probably should write down the quadratic formula in a step before you use the quadratic formula. X equals the opposite of b plus minus the square root of b squared minus 4ac all over 2a. Now let's fill in the next step. So x equals opposite of b is -6 plus minus the square root of b squared is 6 squared minus 4ac all over, all the way to that and all the way to that, all over 2 times 2. All right, I'm gonna scooch a bit over to do my continuation over here, but let's take a little sneak peek at what's going on in the discriminant or in the radicand. So just to spell out some words for us, radicand is the name of an expression underneath a radical. In the case of the quadratic formula, specifically b squared minus 4ac, that is a special radicand, more specific, a subset, so that is the discriminant. Hopefully I'm spelling this correctly. I'm 99% sure. Yeah, I'm sure. Discriminant, b squared minus 4ac, specifically. So I'm going to figure out what that's equal to. Now, 6 squared is 36. I gave you some advice on saving multiplying by 2 for the end. And here I have 2, 4 is also 2 and 2. So let's start at the 7. Times 2 is 14. Times 2 again is 28. Times 2 again. Please be careful. Some of you are not good at mental math when you have to carry. 28 and 28, well, 30 and 30 would be 60. So 28 and 28, 56. 36 take away 56, definitely negative. Definitely, right? So let's get a move on. Here we go. X is negative b. Nope, negative 6. Sorry. Duh, negative b. Plus minus the square root of 36 minus 56. Maybe you thought of this as 8 times 7, but not all of you know your 8 or 7 or 9 times tables because we rely on our calculator and we don't have any common sense. Not good. I didn't say that. Who said that? All over 2a. So, sorry, my dog really wants to play. All over 4. If you hear him whining right now, I'll play with him after this example. Now, 36 minus 56, if you don't get a negative number, you are not paying attention. Your brain is so busy doing very basic things that you cannot even pick up on the fact that 36 minus 56 should be negative. That is not good. That means you need to work on memorizing your basics because it's clouding your judgment and your vision to the finish line. So if I'm doing 36 minus, 56, oh my gosh, my little animal. I might do something like, well, I might start with 56 minus 36 and flip the sign. And you could even do 56 minus 6 minus 30 in your head. These are things I don't write down normally. I'm just showing you. So x equals negative 6 plus minus the square root of. 56 minus 6 is 50. 50 minus 30 is 20, but should be the opposite. So negative 20. All over 4. Now, what is it that builds 20 for us, right? Well, the negative turns into I, our imaginary unit. But 20 is 4 times 5, which is 2, 2, and 5, right? So, scooching that over. This is my sad little factor tree. I, out front, x equals negative 6 plus minus. Takes a pair to make a square, a pair of 2. So we have 2i, I'm so sorry. Square root of 5 over 4. Buddy, what's the matter? Do you want to do quadratic formula also? Come here. Come here. Okay. So I'm going to knock a 2 out of everybody here, okay? Negative 6 will become negative 3. 2 will become 1, or just I. And the 4 in the denominator will become a 2. So this is the first example where we actually still have something in our denominator because it didn't fully simplify. X equals, and that's fine. There's nothing wrong with that. Negative 3 plus minus I root 5 all over 2. So, sorry, a little messy, a little squished. I have 2 imaginary solutions or complex solutions because it involves both real and imaginary parts. Negative 3 plus I root 5 all over 2 and negative 3 minus I root 5 all over 2. Those are exact solutions. We don't need to approximate anything. We're not busting out our calculator. Rad 5 is beautiful. We love it. And we didn't leave a negative in our radical, and we don't have I to a power other than I to the first, so all is good. And if you also got that same answer on your own, give yourself a high five, give yourself a pat on the back, give a video a thumbs up so I know you're a genius. If you got it wrong, if you hate this, if you got it, close, but you're sad, put a thumbs down. Let me know how you're feeling, okay? So hopefully a thumbnail pops up for an example you'd like to see, or maybe you want to jump to the playlist of examples that are similar to this. We'll branch off a little bit in a couple directions. We'll see some cubic and we'll see some quadratic binomials as well. And yeah, carry on. See you later. Adios.